So good morning students. In the last video we have learnt about the conversion, that is number system we have learnt. Okay. So this is for the computer science student. So as you are learning the maths, physics, chemistry, so this topic will be the additional topic for you. Okay. So this topic is not included for the computer application students. This is only for you. For that is those who are learning maths, physics, chemistry and computer science. Okay. So what is this is in second lesson 2, that is part 2. Okay. Chapter 2, part 2, that is Boolean algebra. Boolean algebra. So you must have learnt in the 10th standard what is algebra, you know very well. So it will be write an expression or like. Or next, today we are going to learn in this part is a Boolean algebra. So what do you mean by the word Boolean? That is true or false. Okay, that only will be saying as a Boolean value. That is, it can have only one value, either true or false. Okay, that is, have you written the second midterm exam? You will be saying either yes or no. Have you had your breakfast? You will be saying yes, I had a breakfast. No, I didn't have a breakfast. So only yes or no question. Okay. So how many questions you wrote in the detail means you will be saying 2 or 3 like that. That is not an yes or no question. Okay. So what are all you did yesterday means it is also is not a yes or no question. So you know what is an yes or no question. It can have only either yes or no. So that type of question is called the yes or no question, that is logical question we will say. So that one is called as the Boolean expression, okay, or Boolean you will be saying in the computer language. So scientists name Boole, after this word only this Boolean algebra was taken over. Okay. So here Boolean algebra, so we are going to learn about it. So here we will be in this chapter we will be learning about the circuits or gates. Okay. So in physics you will be learning the circuit diagram. When this one wire it is connected to the positive circuit and another wire is connected to the negative circuit, that like that you will be learning in your physics, isn't it? So the same thing you will be having here, but you will be learning it as a gate, that is the basic gate circuits you will be learning. So what are all the logical gates? So you know what is a logical expression. So we are going to learn about the 3 basic logical gates. So what are all the 3 basic logical gates? That is and, or, and not. Okay, maximum we will be writing this in the capital letters only, and, or, and not. So these are all these 3 are the basic gates, logical gates. Okay. So what do you mean by and or not? As per the name you know what does it has. And means it must have both, or means this or that, not means the opposite sign, isn't it? The same thing only will be having here. So you know very well system accepts only zeros and ones. Also in the circuit also it will be having only either positive or negative, isn't it? So we in the second chapter when you are learning the number system itself, we have learned for positive number the last bit will be having the value 0, and for the negative numbers we will be having the last bit as 1. So we will be having the zeros and ones. So the same thing we are going to perform here. So what are all will be the values? It has been given as the tabular column. Okay. Suppose A and B. I am having 2 variables and I am having 2 values here 0 0, 0 1, 1 0 and 1 1. So what do you mean by the and? And means it performs the similar mathematical operation to dot operator. Dot means multiplication. Okay. So that is A dot B. Okay, that is the and. So you may not confuse and it ends in D, so it means dot operator. You must be very clear about that. Don't confuse. And means dot or plus. Don't have that confusion. To have a clear memory, and it ends in end, so it means dot operator. For dot also it starts with D. Okay, so you have that, and don't confuse whether for and you will be having dot or what else? plus, okay. So A dot B, so 0 dot 0, that is 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, only 1, okay. That is, when you are having the two signals as 1, then only you will be having 1, for all other you will be having 0. You can write this as the same multiplication law, because when 0 is multiplied with anyone, you will be having the 0 only. But here when we are writing in the circuit symbol, it is written as A dot B, okay. So A dot B means AND operator, so it has the following values, clear. And next we are going to learn about the OR operator. OR, it means it performs the calculation similar to the plus operator. In mathematics we will be using plus operator, 1 plus 0, 1, 0 plus 1, 1. So that is, either one value must be having a positive value. Here only if you are having both the positive, then only you will be having the positive, like that we will be having, okay. So now we will see the OR. So the same thing, I am going to give two values. So 0 0 0 1 1 0 1 1. So here I will be specifying as plus. So 0 plus 0 0, 0 plus 1 1, 1 plus 0 1, and 1 plus 1 also will be having 1, okay. So this is the values that has been given for the OR operator. So in OR, either if 1 has the value 1, it will be having the value 1, clear. So it performs the calculation similar to the addition operation. So these are all the AND and OR gates, the basic gates. Another one basic gate is NOT. So it performs as the Boolean, that is, if A, then you will be having the NOT, A bar we can say, okay. NOT means, so if you are having 0, here 1, if you are having 1, here we will be having 0, clear. So these are all the basic 3 gate operation, AND, OR and NOT, okay. So AND means dot operator, OR means plus operator, and NOT means the opposite one. 0 means 1, not the opposite, the inverted one. 0 means 1, 1 means 0, clear. So these are all the values. So this has been given in your book as a tabular column. So if you are asked to explain the 3 basic gates, AND or NOT are the 3 basic logic gates, clear. So now let us see the circuit for this 3 gates, basic gates. What are the 3 basic gates? AND, OR and NOT, okay. So for AND, so as I said earlier, AND it is similar to the performs as the dot operator, isn't it? So how will be the circuit? Suppose I am giving here, so here I am giving A and here I am giving B. So 2 signals are given as an input and I am getting only one output, let it be C. So how does this C perform? What does action happens in the AND gate? So this is the AND gate, that is, it is described as the D symbol, okay. So here what we will be having is A and B are the 2 input signals and the only one output will be having as C. So what does it perform? C is equal to A dot B, that is A and B. So how it is performed? Using the operator dot. So A dot B. So in AND gate you will be expressing it as D. There will be 2 input signals A and B and only one output signal. How does it perform? The C is equal to A dot B. The same one, the circuit just changes for OR. So for OR also we are having A and B as 2 input. So it will be given as like this, okay. So it must be drawn like this, okay. There must be a bend. Don't draw it as a straight line. It must be as a curve, and here also it must be as a curve. Don't draw like a triangle. It must be bend. So this is the OR gate, and it will be also having only one output C. So how it is performed? C is equal to A plus B. So this is the symbol for the OR gate, A and B. So this is the OR gate symbol. So it is in the bend shape. So it will give only one output, C is equal to A plus B. So if A and B has, if A has 0 and B has 0, what is the output? We have seen in the tabular column. If A and B has 1, what will be the output? We have seen in the tabular column. So for AND gate also you know, and OR gate also you know what type of output will be performed. And next, what will be the for NOT? Okay, so NOT means we will be representing as it as a one circle only will be representing it. That is, when we are using it for a triangle, okay, A, one input only will be giving, so A, so only one output will be giving as A bar. Okay, so for NOT operator we will be using the like this one triangle symbol only will be using, so only one input will be given. So what will be the output? That is A bar. 0 means 1, 1 means 0. So this is the circuit we are using for the AND gate, OR gate and NOT gate. You should use the symbol correctly. For AND gate means you should use the D symbol like this, and for OR means it must be an curved one, bent one, and for NOT it must be a straight line with a like a triangle shape. Okay, so these are all the three basic circuits. So you should not change this symbol. Both AND and OR will be having the two. Sometimes they may be having the another AND gate and OR gate. Let us see in the upcoming videos. Okay, so here these are all the basic three circuits: AND circuit, OR circuit and the NOT. Now we will see the combination of this. When what happens when AND and NOT are combined, and what happens when OR and NOT are combined. Okay, so when AND and NOT is combined, we say it as NAND gate. Okay, NAND. So three basic gates we have seen. What are all three basic gates? AND, OR, NOT. Okay, these three are the basic gates. When AND gate is combined with NOT, we call it as NAND. Okay, and when OR gate combined with NOT, we call it as NOR gate. Okay, AND gate with NOT and OR gate with NOT. So we call it as NAND and NOR. So now we will see how this circuit can be drawn, and what are all the inputs we have given, and what will be the output will getting out. Okay, so let us see now. AND gate, as I said earlier, it is a combination of AND and NOT. So it is the combination of AND gate and NOT gate. Okay, so you know very well for AND what is this? So C is equal to for AND A dot B. So NOT means complement. So therefore NAND gate will be having C is equal to A dot B bar. Okay, so the NOT of AND. So that is A dot B is the working process for the AND one. So A dot B. So the NOT means A dot B the bar. So that will be the NOT gate, sorry, NAND gate 1. Okay. So how it is performed? So suppose we are giving A and B, the same values will be giving 0 0, 0 1, 1 0 and 1 1. So what will be the value of A dot B? That is AND gate. Okay. So for A dot B 0 0 0 1. Now I am going to A dot B the NOT, that is NAND. I am going to find the complement or the in NOT process of A dot B. So 0 1 1 1 0. So this is the, what is this? For NAND. For NAND gate we will be having this value. So here I have written in this, first I have performed the A dot B, then I have performed the A dot B the whole bar, so that it will be very clear for you, you can understand easily. So when they have asked to explain the NAND gate, you must write what is the input, that is A and B, and next you should not write this, you should write this only. Okay, A and B, and what will be the output? What is the NAND gate symbol? A dot B the bar. So that is the symbol for the NAND gate, and what will be the output? Okay. So if you get confused, you can write this. Write the third step. A dot B and then the A dot B the whole bar. But it is very clear, so that for if you are asked to explain the NAND gate, you can write A, B and what does the symbol for this? A dot B the whole bar and the value. Clear? So this is the NAND gate. So NAND gate is the combination of and NOT. Clear? So and NOT gate only gives the NAND. So for what is the symbol is A dot B the whole bar, because A dot B belongs to AND gate and the NOT symbol when we are implementing on it, it becomes the A dot B the whole bar. So that is the NAND gate. So now how will be the circuit for this? So in circuit we are having A and here we are having B. So for AND we are having this symbol. So and then you must be using the NOT symbol, isn't it? So here it is A dot B and when it is passed to a triangle, it becomes A dot B the whole bar. Clear? So this is B and the NAND gate. So this is the generally we will be describing this like this. Okay. So here we will be so when A and B gets the input AND gate and then here comes the NOT gate, isn't it? So we will be having the NOT gate like this and then we will be having A dot B the whole bar. So I have split it as AND gate and the NOT gate. We can combine this and use in a single symbol. So how we write this as A and B and we will be drawing as the D, and instead of drawing a triangle and a circle, we will be here we will be adding one circle. So with this it gets the output C is equal to A dot B the whole bar. Okay. So we can express NAND gate in this. So generally NAND gate and then it is we are implementing the NOT gate on it. But when we are combining this both and NOT, it becomes the NAND gate, no? So NAND means a D with a circle at in the curve part at the right hand side, and then it will be you will be expressing your what will be the output, that is A dot B the whole bar. So A, B, this is the NAND gate. Clear? So NAND gate is the combination of and NOT. So you know very well. So when we are expressing it, you will be expressing it at A dot B and A dot B the complement bar. So when we are expressing in the circuit, you will be expressing is like this. Suppose they have asked to explain NAND gate means first you should write it is the combination of and NOT. So for AND gate you will be having A dot B. For NAND it is C dot A dot B bar. And what will be the output? When we are giving the what set of input is given, what will be the output we are getting? You have to draw this tabular column and then you have to draw this circuit. You have no need to draw this circuit. By splitting, you no need to draw this circuit. If you ask the NAND gate, you can directly draw this NAND circuit. So for your clearance only, in your book, and I have also explained that and then of NOT. But in exam, if they have asked, you can directly write the NAND gate. Okay. So NAND means with D and a circle here. So NAND, I think NAND gate is clear for you. It is a combination of and NOT. The same principle is followed for the NOR gate. NOR gate is the combination of NOT and OR. Okay. Now we will see it. So NOR. So NOR gate, it is the combination of NOT and OR. Okay. So for OR gate, what will be there then? C is equal to A plus B. So plus is for the NOR. So for NOT means we will be having C is equal to A plus B the whole bar. That is for the NOR gate. Okay. So NOR gate has the expression C is equal to A plus B the whole bar. Okay. Because R means A plus B. So it's not, when you are applying not for that, it becomes the C is equal to A plus B the whole bar. So now we will check here. So what happens here? So when we are giving the input and it must be performing the OR operation here and then comes the NOR operation. So for OR, what is the tabular value? So 0 and this one only will be the 0. All others will be having the value 1. So now here NOR means a plus b the whole bar. So 0 complement 1, 1 complement 0, and then it has the, so this tabular column is for the NOR gate. Clear? So a and b, a plus b has the OR value and a plus b the complement gives the NOR gate values. So what will be the output? 1 and 0 0 0. Clear? So now let us see the diagram. So as how we have implemented in NAND, we are also going to implement in NOR. So first a and b. So for OR it must be bend. Okay. Here you will be having C is equal to a plus b, and when we are applying here the NOT symbol, it will be as a plus b the whole bar, right? So this is the OR and this is the NOT. So when we are combining, we will be getting the a, b. So the same thing. So in NAND gate, we will be giving one circle here, no? The same thing is processed here, and you will be giving C is equal to a plus b the whole bar. Okay. So this is the NOR circuit. So you must draw a curved triangle. With this you must be having a circle at the tip of this. So it gives the output. So we are having 2 input and 2 output. What is the expression for NOR? C is equal to a plus b the whole bar. Clear? So up to this we have learnt about the 3 basic logical gates, and when those 2 basic logical gates when combined each other, what gate they form and how does it works. Okay. So what are all the 3 basic logical gates? AND, OR and NOT. So AND, OR, NOT. These 3 are the basic logical gates. AND gate means A dot B, OR means A plus B, and NOT means A complement. Clear? And when NAND is combination of NOT and NOR, it is a combination of NOT and OR. Okay. What is the expression it has? It has the expression A dot B the whole bar, and it has the expression A plus B the whole bar. Clear? So 3 logical gates, AND, OR, NOT. The expressions are A dot B, A plus B and A complement, and when these inside this, when AND and OR and NOT combine, NAND and OR and NOT combine NOR. So A dot B the whole bar and A plus B the whole bar. So these 5 logical gates we have seen today. So be clear with this. Next only on basic gates only we will be learning the other gates. So we are having bubble gate. So how we can perform we will see in the next video. So be clear with this basic gates. Then only you can be able to understand the other gates which are coming in the next. Okay. Thank you students.